All right, so welcome back. So now we want to look at one that's probably going to be a little more work to graph, and that is r equals 2 cosine of 3 theta. R equals 2 cosine of 3 theta. So once again, I'm going to turn to the xy graph. Y equals 2 cosine of 3x. And y equals 2 cosine of 3x. And I want to look at that graph and start looking at what's going on with the graph. First of all, I have a 2 in front, so I have an amplitude of 2. And then I have this 3x. I have this 3x. So what's going to happen when you're computing this is the angle that you pass into at x is going to get multiplied by 3. In other words, that means you're going to get around the circle 3 times as fast. So that the period here, which is normally 2 pi, will actually get done in a third of the time. In other words, we'll have a period of 2 pi over 3. So that means from 0 to 2 pi, we're actually going to have 3 cycles of the xy graph. Now we could graph this by hand. I'm just going to go ahead and use my Desmos to graph this, just so it saves us a little bit of time. So there's my graph. And I need to go until I get to 2 pi. So let me do a little bit of adjusting here on my x-axis. I'm going to go negative pi to 3 pi, so I get enough of the graph. I'm going to set my step here at pi over 6. That way everything will be nice. We'll zoom a little bit here. Come back in here a little bit. So there we are. We see the full graph there stops at 2 pi. And what we're basically doing is we need to know what these values are here, where it hits its quarter points and so on. So normally the quarter points are things like pi over 2 pi, 3 pi over 2, and 2 pi. But now they've been adjusted. They've been adjusted now because of this period changing. So we do need to know what those are. Fortunately, they're easy enough to figure out, as I'll show you here. So your original one would have been pi over 2, but everything is basically getting divided by 3. So if you take pi over 2 and divide it by 3, you're going to get your first point there, which is actually pi over 6. So that's actually going to be your increment. So the next point of interest will happen there, halfway in between, at pi over 3. So I'm actually going to move my, let me do a little bit of drawing here. Let's move him. Well, I thought I was moving him. Try this again. If it will let me. Keep hitting the wrong buttons. There's my pi over 6. Again, the next point. I'm sorry, my graph just is going crazy here. Let me get back in here. So our next point here will be at pi over 3. Then the next point is another pi over 6. So pi over 6 plus pi over 3 is actually pi over 2. And it hits its first point here at 2 pi over 3. In other words, it's going up by 30 degrees each time. Okay, so if you want to think of it that way, and then you just keep working out your points. So your next point here would be another 30 degrees, which would actually take you, we know that this one's pi, to 5 pi over 6, and then pi. And then we're on the other side here at 7 pi over 6. The next one here would be at 4 pi over 3. Eventually we'll finish over here at 2 pi. Now, I'm not going to worry about writing down the other ones, but I want you to see this. The first increment was pi over 6, and you just keep getting that increment every time to get your next point. You have to do a little bit of fraction idea. You can also think of it in degrees if that's easier, because when you're graphing the polar graph, a lot of your polar graph paper is actually marked in degrees. So if you want to do it that way, you certainly can. Okay, so let's use this information now, and let's start trying to piece together the graph of our r equals 2 cosine of 3 theta. So I'm going to come in here and pull out my polar graph paper again. Once again, my y values are ranging between -2 and 2. Okay, so I can mark that again, kind of as I did before, with a half, a 1, a 1.5, and a 2. Now, what's really important here is when we're looking at the XY graph is we really pay attention to the times when the XY graph is positive and the times when it's negative. So I'm just going to do a little bit of highlighting here. Positive, 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 and then it's negative here, negative here, negative here, and now we're done. Actually, I didn't have to go quite as far there. Let me take those off there. We're only going to there, 2 pi. Okay, so every time that it switches from being positive to negative, those are going to be times that I'm going to want to mark on my graph. So at pi over 6, it switches. It switches back at pi over 2, at 5 pi over 6, at 7 pi over 6, whatever this point is, and this point right here before 2 pi. So let me go over there and mark those. And what I'm going to do with those is I'm going to mark those as a dashed line. So at pi over 6, I'm going to have a dashed line there for pi over 6, and also for pi over 2, a dashed line. Okay. Also at 5 pi over 6, I'm going to have a dashed line. And continuing this pattern here, a dashed line here at 7 pi over 6. And then we'll worry about the other ones as we come to them. Okay, so just kind of marking a few things here, information-wise. Here we are at pi over 6. Again, here's at pi over 2. Okay, so what do we see here to start off with? Well, first of all, my function starts at its highest point, which is 2, and that's at 0 radians. And then as it approaches pi over 6, it goes down to 0. So we start out here, all the way out at 2. Now, as we move towards pi over 6, right, so as the graph is circling through, that radius is going to keep shrinking until when you hit pi over 6, you're actually going to have a radius of 0. You're actually going to have a radius of 0. Okay, you're actually going to end up with a radius of 0. Okay, so you may want to go in here and plug in a midway point, like 15 degrees. So if I'm throwing myself, I think I'm in degree mode now. And let's do this. My function again was 2 cosine times 3 theta. So 2 times the cosine of 3 times 15 degrees. Okay. And I get 1.4. So here at the 15 degree or pi over 12 mark, I have down to 1.4. So you can plug other values in if you want. But once you kind of start to get the feel for these, you'll be able to graph them well, I think. As we turn around, we're going to be coming through, keep turning, keep turning, keep turning, till I reach that pi over 6 where it's going to hit 0, Okay, so now I have the first little wing there of this graph. And we return to our graph. Now the next part, we go from pi over 6 to pi over 3, it drops from 0 down to -2. So normally, this would be happening in this little range here. This part of the graph would be happening inside the pi over 6 to pi over 2 area. Right? So what would happen is you would be growing from 0 out to 2, and then you'd actually be coming back. So you'd get this kind of shape here. However, it's negative, so everything is pushed through on the bottom. Everything is going to be pushed through. And so instead of happening here, everything is going to be reflected through, and you're actually going to be happening here in this range. Okay, so what's going to happen is at pi over 3, it gets all the way down to -2. So if I look at pi over 3 here, and I'm going to have to come through in the backwards direction to -2. So I mark that on my graph out here at -2. Okay, again, you may want to put some other values in, like 45 degrees. Maybe you might want to pencil this guy in, right, to get a few extra little points there. So you may want to go in and plug in your 45 degrees. So, it's -1.4. Or your 75 degrees. Oh, it's also -1.4. Okay, and we draw those points. So what's going to happen is it's going to be coming out. Early on, it's going to be hugging the line, but as you get further, it's going to swing all the way out. And then as we approach 3 pi over 2 here, it's going to do the same thing. So kind of growing back in, we get this kind of a loop here, kind of a loop or rose petal, if you will. All right, and we keep going. Now we've passed pi over 2, so we're back into the positive stuff. So as we range between pi over 2 and 5 pi over 6, we're back in the positive direction. We're going to hit a high point there at 2 pi over 3. So we're actually back into the normal graph. So at 2 pi over 3, we're all the way out here at a radius of 2. And what's going to happen again is you're going to be hugging that point for a while. So it comes out, coming back. As you approach that thing, it's going to kind of hug down as well. And now we're back to 0 again. Okay. And now that puts us in to 5 pi over 6. Between 5 pi over 6 and 7 pi over 6, we are now once again negative. So that part of the graph would have been ranging here, but it's going to be reflected through so that it's ranging here. So it's now going to be ranging over here. It's been reflected through. Okay, and so we do that. So it normally would have been happening here, but it's been reflected through. So what's going to happen is at pi, it's going to be at -2. That would actually land you back to this point. I'm going to draw in another, get back here. My gosh, my thing just doesn't want to behave today. So let me get another dotted line, dashed line in here so I can mark this for you. Okay. So it's going to be coming out from that dotted line. It's going to come out to its high point, which graph-wise would be at pi, but it's coming through the negative, so it's over here at 0, and it'll come out to 2. Okay, so coming out from the dashed line, and we hit our point. And then we would actually come back, which would actually just trace back over this part of the graph again. Okay, and now we're back to the positive direction. So then we're ranging here from 7 pi over 6 to this point here, which would actually be 3 pi over 2, if we worked it out. And we're in the positive direction again. So what's actually happening is, here we are, 7 pi over 6 to our 3 pi over 2. We're actually ranging from 0 out to 2. And so you actually see that we're actually regraphing it again. And then what's going to happen in this next part here is you would be negative. So that graph actually, when it hits the next point, is coming back through like so again. And then finally you'll be down into the fourth quadrant here between 11 pi over 6 and 2 pi. And that's where you're going to get this last part where it's positive again, right here. And so we actually end up getting a 3-petaled rose here. We actually end up getting a 3-petaled rose here with this example. Okay, so in general, when you graph stuff like this, what you're going to see is with both r equals a sine n theta and r equals a cosine n theta, is that if n is odd, as was the case here, you're going to get an n-petaled rose or flower, because that's what it looks like. And if n happens to be even, then you're actually going to get a rose petal with 2 n petals. Because what happens in the odd case, is it's actually, once you get halfway through, you've got the whole graph. That doesn't happen with the even ones. Okay. So here we have our graph. And again, we did it without plotting nearly as many points this time because we used the basic idea of this lightsaber in a cornfield. Right? Lightsaber's all the way out at 2, and it's slowly shrinking to 0 as we go towards our first turn through our first 30 degrees. It's the negative, so the back guy's opening up for a while, and you hit that part. Right? We're then back to positive, the front guy's coming out and hitting it. Then we're negative, so instead of growing here, it's coming back here. And then we've actually keep turning, but now this stuff is reflected over here. This stuff just repeats. Stuff that would have been here is coming out the back one. And then finally you're finishing it up again. Okay.